The least common multiple, or LCM. By definition, the least common multiple is the smallest multiple shared by two or more terms. So if we look at the terms 6 and 8, I can find common multiples between them and find the least one. So I have 24, 48, I have 72, I could keep going, but I won't. And I can see that the least common multiple equals 24. Now I know you might be asking, but Miss Carla, how actually do we know this? There's 3 methods to find the least common multiple. The first method is by listing the multiples of each number. So let's look at the first example of 12 and 15. To make myself have a little bit more clarity on how I list the multiples, I'm going to do a chart, and I know that I'm going to be multiplying by the following numbers for sure. And I could keep going as many as I need, but I might not use them all. I might only go up to 7. So now 12 times 1, 12 times 2, 12 times 3, 12 times 4, 12 times 5, 12 times 6, 12 times 7, and 96 is the last one. Okay, let's do all the multiples for 15. So I have 15, I have 30, 45, I have 60, I have 75, I have 90. I'm going to stop here because if you look, I have 60 and I have 60. So that means that the LCM equals 60 for 12 and 15. And on a test you could write it this way and it would be acceptable. What happens when you have 3 numbers and they're bigger than 12 and 15? I'm going to do the same thing. I'm going to make my chart. And I'm going to go up to 10 for this one, just because it makes it a little bit easier for me. So, all of the numbers, I'm going to start with 18, 36, keep going, 54. Bear with me while I write them all down here. And 7 is 126, 144, 9 is 162, and then I finally at 180. And again, we could keep going, but I'm just going to stop at the multiple of 18 times 10. So let's look at the number 20 and write out all of these ones. That's 40, 60, 80, 100. 120, 140, 160, 180, 200. And I'll do the same thing for 30, 60, keep going, 90, 120, 150, 180, 210, 240, 270, and 300. Is there a commonality between these? If I look, I can see that I have 60 and 60. While these are common for only 20 and 30, it is not included in 18. What's the next one? Oh, I have 90 and 90. It's not included in 20, so that is not it. Is there one after this? We have 120 and 120. Nope, because it is not in 18. I'm going to keep looking here. I have 180, 180, and 180. Ah, there it is. That's my least common multiple. So therefore, my LCM equals 180 for 18, 20, and 30. That seems like a lot of work, especially if you have larger numbers. Let's see if there's an easier way to do it. Let's look at method number 2. It might be a way that you find less work and easier to handle. So for method 2, you check to see which multiple of the largest number only is also a multiple of the other terms. So I'm only going to put the multiples for the number 30. So that's the largest number. So I'm going to write down 30, 60, 90, and I'm going to keep going, 120, 150, 180, and 210. I'm going to stop at 240. I think that'll be enough. So again, it's 1, 2, 3, 4, 5, 6, 7, and I stopped at 8. So now I'm going to see 18. Where does it divide exactly into? So let's see. It divides exactly into 90, and you can use your calculator for this, and it also divides exactly into 180. Let's look at 20. What numbers does 20 divide exactly into? And if we look, it divides exactly into 60, 120, and 180. And now we have some commonality. We have 180, 180, and 180. So therefore, our lowest common multiple is 180. Pause the video and try your turn at this, looking at the numbers 20 and 25. Once you're completed, turn the video back on to find the answer. Welcome back. The answer for the LCM for 20 and 25 is 100. Let's take a look at our third and final method for LCM. The third method is where we write the prime factors of each number, highlight the greatest power of each prime factor in any list, and then we have to do something with them. So let's first find out the prime factors. So if we look at 18, I know it's 2 times 9, so I'm going to quickly go 2 times 3 times 3 and rewrite it as 2 times 3 squared. I know 20 is 4 times 5, so I'm going to break 4 up into 2 times 2 times 5, and I'm going to rewrite it as 2 squared times 5. And I know 30 is 2 times 15, so I'm going to write 2 times 3 times 5. You could also do it by the tree method that we learned earlier in earlier videos. That's a messy 5, so let's clean that up. And we can't rewrite this any other way. It's just 2 times 3 times 5 because there's only one of each. So let's look at the highest power in each. So I have 3 squared, that's a higher power than 2 to the 1. 2 squared is higher than 5 to the 1. And these are all to the power 1, but 5 is the largest number. So now what I have to do to find the LCM is I'm going to take the product. So that means I have to multiply of the greatest powers of each prime factor. So product means multiply, so I'm going to take my 3 squared, multiply it by my 2 squared, multiply by my 5. What do I get? 9 times 4 times 5. And if you plug through that, it equals 180. So my LCM equals 180. That's exactly as we found it before. Take your turn and try your hand at the numbers 18, 27, and 36. Pause the video, then come back and find the answer. Welcome back. Hopefully you got the LCM equals 108.